My name is Naomi Hallas. I'm a professor at Rice University in Houston, Texas, and I'm a member of the Nanoscience Selection Committee. And I'm very excited about the presentations this afternoon. I was very excited about awarding the Kavli Prize in Nanoscience to Jakob Sagiv, Ralph Nuzzo, David Alara, and George Whitesides for their pioneering work in self-assembled monolayers. So today we'll hear first a recorded presentation from Ralph Nuzzo, and he will discuss, of course, his work collaboratively with Dave Alara and also George Whiteside's work. And then Jakob will, after we have a brief break, we will hear from Jakob Sagiv. So I thought that I would add a little bit extra dimension to this that probably is not going to be discussed. I'm not sure, but it's probably not going to be discussed by the speakers. And that is for us to look at the impact of self-assembled monolayers on society, on industry. And what this is a chart that we obtained as we were working on this project that shows the number of patents that resulted from self-assembled monolayers. And also, so the thing that of course impresses you immediately is you see the number of patents, which is hundreds and hundreds of patents, but also look at the different fields. They are so broad to see what incredible impact self-assembled monolayers has. We were stunned and we were so excited because we realized, of course, one of the missions of the Kavli Foundation is impact on society. And so this is one of the most impactful in terms of how the breadth of this breakthrough in nanoscience and how many different fields it has impacted. And you can also see this list of all the different companies and some of their work. And some might be surprising because IBM is at the very, very top of this list. I found that very interesting. And some of this has to do with actually another aspect of this prize that also has resulted in a very large impact to society, and that is the whole idea of microcontact printing. So once self-assembled monolayers were discovered, and demonstrated in several different material systems, this is really something I believe that this is from a group at ETH. So this is far after the initial discovery and the initial ideas about microcontact printing, but the idea of using an elastomeric mask and putting molecules on that mask and then patterning the molecules on a substrate was really something that had very far-reaching implications because you can go from small molecules to very large molecules to biomolecules very quickly. And one thing that this has led to is something that you will all find very familiar. So this is, you might not have seen it in this scale, but this is a lateral flow assay. This is a COVID test. Right? And so the technologies that we hear about today, they have laid the groundwork for lateral flow assays. That's one name of them, or point of contact devices. At lunch we were talking about lab on a chip. So many of the ideas now that are very mature, completely new field, originated with the work of Jakob and Ralph and Dave and George.